Knox Game Design, June 2023. Grid-based games. Welcome everyone to Knox Game Design for June 2023. My name is Levi Smith. So this month we're going to be talking about grid-based games. So here's some examples of grid-based games right here. Checkers, chess, Scrabble, Battleship. I consider these types of games to be good for beginners to implement because you're dealing with pieces assigned to a place on a grid. You're not having to deal with real-time coordinates. You can either do a 2D or 3D based game. So some of the decisions when you're making a 2D based game, and in this example I'll be walking through how to make a checkers game. You want to start out with a 2D array, but in checkers you don't actually use all the grid squares. Like, you only use the black squares and not the red spaces. But yeah, for a grid-based game you can have a 2D array and you can assign like a 0 for an open space, a 1 for player 1, and 2 for player 2. Or when you get more deep into it, you may want to actually assign an object to those array cells and just use null for an empty cell. So the layout, one of the design decisions you'll have to make is, does the piece know which grid cell it's on, or does the array just keep track references of all the pieces in the game? And usually that's the better way to do it, and then you can derive, if you ask a piece what location it is, then you can derive from the 2D array the cell that it's located in. Otherwise you're going to be duplicating data, which sometimes isn't good, because then you go into redundancy and data that's mismatched if you have both the piece tracking its location in the grid and the grid having a reference to the piece. So avoid redundancy, and like I mentioned, in some games you don't use all the. So there is some ways that you can make things a little bit more efficient, like in checkers, not tracking the red spaces. However, that makes it a little bit more difficult to read the code because the red squares are in a diagonal every other one. So sometimes it's easier just to go ahead and allocate the whole board, even if those cells aren't being used, just for the sake of making your code easier to read. Okay, so in an implementation of a grid-based game, typically your rows are going to be going up and down, your y-coordinate in a 2D game. Your columns are going to be your x-coordinate going left to right. You got to remember, in most 2D game development environments, your screen coordinates go from top to bottom. So you got to invert your row. So your row, you need to invert it so it goes bottom to top. If you're doing a 3D based game like in Unreal or in Unity or Godot engine, you don't have to worry about that. Your row coordinate is just your z coordinate typically, and what I like to do is put the camera up above looking down, but you can implement that however you want to. If you want to still want to make rows going up and down on the y coordinate, you can do that. Okay, so to create a simple checkers game, and I recommend checkers. I mean, start out easy if you're a beginning game developer, and not jump into full chess or other games like that. Checkers, you need a 2D array, and starting out I just made it an array of ints. Like I mentioned earlier, 0 for an empty space, 1 for player 1 if it has a checker for player 1, 2 for player 2. Now you're going to run into some issues later, so when I started implementing this, I started out using a 2D int array, then I converted that to objects because you run into issues. If you're familiar with checkers, you can, once you get your checker to the other side, then it gets kinged. So then you would need more ints to represent a king, or you could have, I don't know. That's where it gets kind of difficult, and that's where the object-oriented makes things a little bit easier if you're just dealing with objects instead of ints. So again, I'll be doing this example in MonoGame, just because MonoGame runs on a lot of different platforms, and it's free, and it's easy to set up. So you can do this example in many different languages, but for this I'll be showing how to do it in MonoGame. So we'll need 2 images, one for the black square and one for the red square, and these are going to be 64 by 64. They're just completely black or red. There isn't anything much going on, so you can create those either in Paint or GIMP or whatever graphics program you want to use. So yeah, to make the checkered board layout, basically if the array cell, if the row number plus the column number modulo, that's what that percentage sign is, modulo 2 equals 0. So that means so it's kind of like saying this starts out as in the upper left hand corner 0, 1, 2, 3, 4, 5, 6, 7. Then 8 is the next row, 9, 10. So if it's an even square, then it's red. Or if the row number plus the column number modulo 2 equals 1, then it's a black square. So that's a quick and dirty way to make that. So that's the first thing you want to do when you're starting your checkers game, is just to get display on the screen. And thankfully with MonoGame, so I'm using Visual Studio. It's pretty easy to do. You just want to create your 2D array. That's what I have with this int open square brace, comma, close square brace. Then I call it my board, and I preface it with Hungarian notation, I board. Then I have a dictionary of sprites. That's kind of just help me track it in MonoGame. We needed to set the screen width and height. So to get this 512, so it's going to be 512 by 512, 64 times 8, 512, both in row and column. Then we do apply changes, create our new board object, making it 8 by 8. And then on our content, we're just going to load in the space. And later on, I have a checker, which is sprite, which is just basically a circle. So go ahead and load in that checker into our texture dictionary. Dictionary is a C# thing for collections, kind of like a hash. So I can have one hash, like one hash table of sprite objects, texture TDs. I can just reference whatever sprite I want by passing in the string name of that sprite. Makes things a little bit easier. Instead of trying to track a whole bunch of different sprites in your code, you just have one sprites dictionary. So then in our draw, we're just going to use the default, and then we're going to loop through our 2D array by rows and columns. So this isn't the best code right here, but I do while I is less than 8 and while j is less than 8. Really want to have those as constants probably. And then I just do that modulo that I was talking about. If mod 2 equals 0, row plus column mod 2 equals 0, then it's a red. Display the red square. Else if I plus j mod 2 is 1, then it's black square. Then by default, it shouldn't be anything else. But I went ahead and put the else in there, make it red. And then we're just going to draw that right there. So that's all there is to it. So I'm going to show the demo right here. That's basically what I have in the code right here. I'm going to run checkers. So yeah, this is basically just the first step. Just get something on the screen. Get your checkerboard on the screen. Okay, so the next step is create the pieces. So I had to use red pieces and white pieces just because black on black, you wouldn't be able to see the black checkers. So basically what I do is loop through the first 3 rows, and if it's valid space, then we're going to set a checker, set one player one piece white, and then I go through the last 3 rows, and if it's a valid space, and then I'm going to set it as player 2 red. So yeah, then you got to remember rows increase from top to bottom, or you could just invert the y coordinate. And that's why I mentioned right here, don't make the piece color the same as the square color, or else you won't be able to see the piece. Here's the code right here. So this is in our initialize. We're just going to leap through the first 3 rows, set it to 1. If it's a valid space, loop through the last 3 rows from 5, while it's greater than 5 to 8. Then we're going to set it to 2. Again, we're just setting a 1 or a 2 for player 1 or player 2 in that int array. Then in draw pieces, we're just going to, if there is a piece in one of those cells, then we're going to draw the associated checker. Actually, I only have one checker piece image, which is a white circle. So if it's player 1, then I'm going to draw it with a white tint. Otherwise, if it's player 2, we're going to draw it with a red tint. So let me open up the next step of the demo. And by the way, I'll put all the code out there so people can see it if they want to see it. And so I have all the code. I'm not going to go through the code again. So basically all the changes that I mentioned are in here. So this is the next step. I mean, just to get your checkers displayed on the board in the right spaces based on the integer array. So here's some considerations. Is like when somebody plays your game, how do you handle the human versus AI control? So basically, what I like to do is create a player class. The player class knows all of its pieces, and it's a super class. It can be extended either into human control, which is handling mouse clicks, or maybe in some cases keyboard presses, or you could subclass that player into AI control, where when it's the AI's turn, artificial intelligence, make the best, do all your logic for determining the move that it needs to make. And probably starting out, I don't get into the AI control, but starting out, I would just recommend selecting a random piece that's under control of that computer player, and then just moving that piece to a valid destination location. But then once you get further into it, you can do game trees, decision trees, and trying to find the optimal move to make. So that's basically if you're human, using the mouse, AI, evaluate the best. You can use weighted outcomes. That's a whole different discussion there. So in this talk, I'll just be focusing on the human control. So if the mouse wasn't pressed on the previous update and is pressed on this update, then we're going to get the selected grid square. So basically we're going to do the mouse Y location divided by 64 is the row, and the mouse X location divided by 64 is the column. Pretty simple there. Depending on what language you're using, that implementation may vary. Basically I'm tracking the mouse, the previous state of the mouse. If you're doing things like Java, it has an on-click or mouse pressed, so you don't have to actually track the previous state and the next state, but in MonoGame you do. I'm going to display this out as a font, so I got to load in a font into the content manager and track that font up here as an instance variable. Then we're just checking the previous state and the next state, and if it changed from released or from not pressed to pressed, then we're going to get to the selected X and Y position. We're going to track as an instance variable the selected row and column. And then here's a helper function over here for getting the selected row and column, that Y divided by 64 and X divided by 64. And then we're going to draw out the selected row and column down here. So by default, we're going to have selected cells -1, -1. So by default, we're going to have the selected cells -1, -1. So when I click, top left cell is going to be 0, 0. Click the bottom right, and it's going to be 7, 7, because it goes from 0 to 7. Click the bottom left, 7, 0. Click the top right, then it's 0, 7. Click in the middle, then it's 4, 3. So that's the next step, is just to get basic selection of cells working. When you click the mouse, it determines what cell you clicked. So the next step is figuring out what the selected piece is. Pretty simple. So if we select a cell, and if there's a piece in that cell, then that's the selected piece. If we're doing objects, which I'll show in a little bit, then we can select that piece's selected property to true, and then select all other objects, all other pieces selected to false. Starting out, I just check for player 1, and then I use yellow for selecting the highlighted piece. So that's the next step. Yeah, so the next step is when you click on a piece, then it actually selects that piece. And yeah, and you can't select the player 2 pieces. You can only select the player 1. So then when you select the piece, it tells you which piece you've selected. If you don't select a valid piece, and it sets the piece selected to -1, -1. Otherwise, it sets the selected cell that piece is in, like row 0, column 1, right there. Or row 0, column 7, right there. Or row 2, column 7. Yeah, and here's the code right here. So I added 2 instance variables for showing the selected piece and selected piece row and selected piece column. As I'll show in a little bit, I convert that into a selected property onto the checker object, the piece object. And here's how we set the selected piece and row right here. Yeah, so we check and see if the cell that they've selected, if it contains a piece for player 1, then we set the selected piece and row to that location. Otherwise, we set it to -1, -1, just like null. And then when we're in our draw method, we just say if it is a selected piece in that cell, then we set it to color yellow. So that's what I just showed. So the next step is to move a piece. So if a valid piece is selected and you select a valid destination, then move the piece to the destination cell. So if you're not familiar with checkers, you can move 1 space down to the left and diagonal, or down to the right if you're the top player. If you're the bottom player, you can move up to 1 to the left or up 1 to the right. So that's your valid. And only if there's not a piece currently in that position. And we'll get into jumping later. So you think checkers is a simple game, but when you start implementing it, you realize it's a little bit more difficult. There's a lot more considerations you need to make when just doing a simple checker game. So yeah, this is the logic, kind of like pseudocode right here. If you have a selected piece in an open cell, it does not contain a piece, and the cell is valid, it's a black square, and the piece is currently selected, then move the piece to the selected piece to the destination. Move the selected piece to the destination, then set the selected piece to nothing. That's what this code is doing right here. It's checking to see if you have a piece selected and the destination is a valid destination. That's pretty much all you got to know. Okay, so here's our player 1. I've selected the piece, and then he moves down. Selected piece there, he moves down. So if I take this top piece right here and try to move him there, then it doesn't work. It just selects that piece. Or if I take this piece and I can't select, yeah, if you select outside, then it's going to crash because I don't have the extra error checking yet. I do fix that later. And then if I select player 2, I can't move player 2. I can only move pieces for player 1. And then if I get down here and I try to move to a valid spot, but it has an opponent's checker, then I can't move there. So I can only move the player 1 pieces to valid locations. So that's the next step. So you just kind of got to think through this logically and go step by step. So yeah, this is where I change it into object oriented. So I create a piece class, that has the piece's color and the direction which that piece can move. I changed the board array from a 2D int to a 2D piece object. The empty squares are set to null. Created a selected piece instance variable to track which piece is currently selected. So that's another design decision. You can either have each piece track whether it's selected or not, or you have one instance variable saying what the selected piece is. Now, if you're doing like an RTS type game or something where you can have multiple pieces selected, multiple units selected, then you probably want to have the units themselves, the pieces themselves track whether to select or not. But if in a game like checkers, when you can only select one piece, then I just went with having an instance variable for selected piece. So I created a helper function, get the row and column. When the pieces move, set the new space to reference to the selected piece, set the old space to null. Yeah, we don't want to have a piece assigned to two board locations. That would be bad. And also, you may need like a temporary variable. You don't want to unreference your piece from the board and lose the handle to it. So I think what I do, and I'll show it on the next slide. And also, this allows you to move to either player. But yeah, so basically, I take the piece, I assign it to the new location, get the row and column in that helper function. So I set the current piece location to null. Then I set the new location row and column to the selected piece, so I don't lose a reference. Because if you lose the reference to your piece, then it's going to get collected in your garbage collection. You don't want that to happen. So this is basically just changing out the 2D int array to objects. So if you really know what you're doing to start out with, you could have just started out doing piece objects. Probably would have made things a lot simpler. But if you're just kind of working from the beginning as a beginner, it's either to do it with ints to start out with. And we just update all of our functions, like draw and update, to use the piece class. And here's the piece class right here. So we got the color, can it move up, can it move down, and then our constructor right here. And basically why I do a can move up boolean and a can move down is I was kind of looking ahead to once a piece can get kinged, it can either move up or down. So having those as two separate booleans makes it a little bit easier to track. Otherwise, you'd have to have another, like, you could have a boolean for is kinged, and then you could have logic saying, oh, if it is king, then you can move up or down. If it's not a king, then you can only move up or down based on which player you are. But just having it as two bools made it simpler. So a lot of this is design decisions. You can implement a lot of this stuff multiple ways. So yeah, this really I don't think has any changes aside from having it implemented as a piece. And yeah, by the way, once I move, I'm not unselected. Once you move the piece, you should make it unselected because I can move one piece multiple times. There's additional things in checkers that I don't get into, like forced hops. Like, I don't know if it's an official rule or not that you have to hop a piece, or you can have multiple hops. I don't get into that. This is just basic checkers, not the advanced rule. So yeah, here we're checking to see if it's a valid move, if the destination is one row greater, and the piece can move one row up, or if the piece destination is one row less, and the piece can move down. If the column destination is one more or one less than the current column, then you can move to that square. Like I was saying, you could implement this without the tracking the red squares, but then you're going to have like a helper function to figure out what row and what column it is. So here's all the code that I added for that. Just determine if it's valid move. No, by the way, I thought I put the examples. Yeah, demo checkers 8. So here's where we get into hopping. If the destination square is 2 rows greater and you can move up, or it's 2 rows less and you can move down, and the piece between is of the opposite color, then it's a valid move. And then you set the jump piece to the board position to null. That way you get rid of the jumped piece. So you move him down, red. Yeah, so demo 8 has hopping. So I'm going to select that checker and move him down, or I can hop him up here. Still has it where you can move multiple squares on a turn. And it doesn't enforce turns between players. So either player can move at any time. But yet, just be aware, is like if I select with the can move up and can move down, like I select that red checker, I can't move him back until he's kinged. Yeah, so he can hop, but he doesn't get the king ability yet. So yeah, you realize it's like, yeah, checkers is a pretty complex game. I mean, it's pretty easy to explain how checkers works, but when you try to actually implement it as a game, there's a lot of stuff you got to think about. So the next thing is checking game over. After each turn, you loop through all the piece objects. Check to see if piece count for either player is equal to 0. If it is, then the game is over. The player with the positive number of pieces wins. The player who has no pieces left. The other way to say that is the player that has no pieces, no checkers left loses. And then I add a bool to track if the game is over, just because it's easier. Once the game was over, you don't want to let the players move anymore, and you want to display a message saying, hey, the game's over. So that's why I have that as a separate bool that gets enabled when the game is over. So yeah, I'm going through the code pretty fast, and I'm just kind of hand-waving over some of the code. It's all in there. I wrote this code like, I think it's 2 or 3 weeks ago. So I'm trying to go back and remember what I did. So yeah, this now has alternating players in force. So once player 1, which is white, once he makes a move, I can no longer move player 1. I can only move player 2 pieces. And then once player 2 moves, I can no longer move player 2 pieces, the red pieces. But yeah, you should be able to go through now and play through an entire game. Until the game is over. If I can make a valid move here. Like I said, I'm not forcing hops or anything in this. Move the white down, the red up, and the white down. Red up and the white down. Move the red up and the white down. Red up and the white down. And I think I gotta make a hop here. And move the white down. And move the red up, white down. And go ahead and hop that one. Move the white down, move the red up, white down, red up, white down, red up, white down, red up. Oh, white down. Then I have to red up, white down, red up, white down. Oh, I might get to invalid state here. Can only, Yeah, I guess I can't get the game over right there. And I haven't got kings implemented. But yeah, just trust me, it does have the game over state implemented in this. Yeah, just that game is unbeatable at that point because I don't have the king property set yet. That is the next step, king promotion. So after a valid move, if you can't move down and the row equals max rows -1, it means you got to the very end. Then you can set move down to true, or that means you got to the very top. If you can't move up and the row equals 0, then set can move up to true. You got to the very bottom. Then update the checker graphic. So I created a new graphic for the kings in GIMP. Just basically took that checkered, cut it in half, and kind of did the crooked Bart Simpson hairdo type to the top of it there. I'll go ahead and take a look at that. Checkers. I think that's checkers 10. I think. No, that's checkers 11. I guess 10 was the game over. Yeah, I don't think this has the kings yet. Yeah. So demo 10 is just checking the game over. Then 11 is the king. So let's see if we can get some kings here. Then start this one up. Okay. I think I gotta hop this one. Move him up, move him down, move him up, hop him over. So yeah, now I got the king in the lower left-hand corner. Oh, and by the way, in the upper left-hand corner, I do specify whose turn it is. So instead of player 1 to 2, I just got 0 and 1. So 0 is player 1, 1 is player 2. So you can see I got the white checker all the way to the end. And he got kinged. And I got a red checker to the very top and got kinged. So now I can move that red, move the red down. I can move the white up or down. They can move in either direction now. Yeah. And the red king can hop the white king. So yeah, once you get king, that's a pretty powerful piece there. You can move in either direction. So I think I'm going to go ahead and have white lose. So here's where you should be able to double jump, but I'm not tracking that yet. That'll be an additional exercise. The double jump. Yeah, so there you go. It says player 1 wins, but it's actually the red player, the second player. Once one side loses all their pieces. Yeah, double jumping, that's an interesting problem there. So you got to track whether after you jump a piece, then you got to determine, is there another valid jump possible? So you got to leap through. I guess for that piece, you got to leap through all the possible jumps. Is there another valid jump after? And then if there is, then you got to set another flag saying, hey, go again. But I don't get into that for this demo. So yeah, I talked about king promotion, movement. Okay, so this is something I added there at the end. So you can see in the game, it kind of snaps. Whenever you select the destination square, it just snaps to that position. So there really isn't any way to tell that it's moving. You just kind of picture it in your mind if you know what's going on. It's like, okay, it was there, and you're going to this destination, so it moved. But if you really weren't paying attention, it just kind of looks like the pieces are flashing, jumping around. So yeah, you can add some movement, but you got to track the current position, track the target position, and interpolate between those two positions. And that when I say positions, I mean in X and Y pixels, or you could do floats even for even more precision. So yeah, on the piece move, set the target position. When the pieces move, set the target position. Then on update for each piece, while the current position does not equal the target position, move the current position to the target position. You can use lerp. So I'll lerp between the current position of the piece and the destination, which kind of gives a smooth, it gives more of a kind of like a curved interpolation than a linear. To get a perfect linear interpolation, you would have to track another variable, which is the starting position. You'd have to track the starting position, the current position, and the ending position. But if you're only tracking the current position and ending position, then you're going to get a fast to slow. And then it'll eventually reach the target position, or it'll like asymptotically reach the position. And it'll be so close to the target position that it equals the target position. Then you can say it reached its target position and quit moving it. Update the draw method to use that new current position of the piece. Set the current position of the piece on instantiation. Whenever a piece gets created and assigned a row and column, then set the X and Y, the current position for that piece, to the row and column. You just take the row times 64 and column times 64. And also you want to cast your X and Y position to ints if you're using a vector 2. That way you don't get errors. And that's the final part of the demo, Checkers 12. Take a look at it. And I implemented all that in code. I'm not going to go over the code, but it's all in there. So here it is, white. So you can actually see the pieces moving now, which is kind of nice. It isn't great or anything, but you can actually just see the pieces moving. Who do I want to move? Move him up, move him down. I guess we'll have to hop him down, move him up, move him down, move him up, move him down. And I got him kinged. Move him up. Move him down, move him up, move him. So now the king can move either up or down. Him up, move him down. So now I got two kings on the white side. Move him up, move him down. Move him up, move him up. Him up, jump him. Move him up, move him down. I guess that's the only valid move right there. Move him down, jump him, move him down, him up, jump him, move him up, and move him. So yeah, there we go. Player 0 wins. So that's adding that little bit of interpolation in there. Yeah, I can't remember where in the code that is. But there's a LARP in here. It's kind of a nice function in C#. Yeah, there it is right there. So in the update, which I probably should have broken this out into multiple functions, at the position of that piece, actually I should really only track the currently selected. But yeah, if the current piece, for each piece, if the current piece that you're looking at if the current position is not equal to the target position, then we're going to set the current position to vector true LARP, current position, target position. Then we're going to do the 16 time float time, game time. So this is kind of like delta time right here in Unity, basically the time between frames. So we're going to move 16 pixels per frame, or 16 pixels per second. I believe that's what we're doing right there. So that's it. That's a working checker game, a grid-based game. What's left? Double jumping, as I mentioned earlier. Force jumping, that's more logic you'd have to add in there. Don't have any sound or music currently in the game that could be added. Better graphics, do 3D or whatever you want to do. Menus and options, adding the AI to the opponent, and highlight valid moves. Yeah, so that's a working grid-based game. Many other types of grid-based games, as I mentioned earlier, but that's just one example. That's what I'd recommend if you're just starting out making games. Just try to do checkers, and that'll show people you know what you're doing. You can make a basic game, and if you can add computer opponents, AI, things like that, definitely increase the game. And yeah, it probably isn't a game that you put on the marketplace or anything, but you can always polish it up and share it with friends and family, show them what you've made. But so that's going to wrap it up for June 2023. Appreciate everyone out there listening and watching, and we'll plan on being back in a month.